Number 38 in the diagram below, two boxes with masses 3 kilograms and 7 kilograms are attached to the end of a 1 meter long lever. At which of the following points should the lever be placed on a fulcrum in order to keep it at equilibrium? Well, obviously we need to move this box, this fulcrum, closer to the heavy box. But let's see if we can work through why that should be. So we want the torque. So we want the net torque to be equal to 0. So we can say, okay, so the distance for A times the force for A. But since both have G working on them, we can forget about gravity on both and just use the masses here. So we would have 3RA, and we can just call that a distance. Let's get rid of the A. Let's call that A. And that's going to equal 7, and that's going to be positioned at a distance 1 minus R. Right? Because the total is 1, if we're placing the 3 kilogram at a distance R, then the 7 kilogram has to be 1 minus R. All right, so now what we could do is just solve for R. So let's see, we have 3R equals 7 minus 7R. So we would have 10R equals 7. So R equals 7/10. All right, so 7/10 of a meter is 0.7 meters. All right, so we said that the R is the distance that the 3 kilogram was. So 7/10 of a meter is this. And for the 7 kilogram, it would be 1 minus R. For the 7 kilogram, it would be 1 minus R, which is 1 minus 0.7, and that's going to be 0.3 meters. All right, so the fulcrum obviously should be placed at point D.